Hello my beautiful students. In today's lesson I'm going to explain the ribosome. So let's go. Anyone who goes to Google and type eukaryotic or prokaryotic cell anatomy will see both of them small dots called ribosomes. Well, if you get closer look, ribosome they look like this. His structure is made of two subunits, one called the big subunit and the second is the smallest. Eukaryotic and prokaryotic ribosomes are different in their composition. So let's start explain the prokaryotic ribosome. So the big subunit is made of 15S. The S is meaning a unit of sedimentation discovered by Svedberg. We found also the ribosomal RNA. We found the RNA R23.6 and the RNA R56. Also in the big subunit we found a total of 31 proteins. In the smallest subunit made of 13S and RNA 16S and total of 21 proteins. The big unit regrouped with the smallest. The total of sedimentation is 17S and not 18 because the sedimentation technique don't count like normal number. The total of sedimentation is different when they regrouped and separated. Now let's go and talk about the eukaryotic ribosomes. The big subunit is made of 16S and RNA R20S and 5.8S and 5S and total of 46 proteins. In the small subunits we get 14S of sedimentation and RNA R18 S and total of 33 proteins, and total of sedimentation when the big and small subunits united is 18S. In some pictures you will find that ribosome has three sites, U and P and A. This is not a really sites, they are theoretically agreed by scientists for the reason why they name it like this. The A is for the next amino acid, P site is for premier amino acid liaison. In that site, peptide liaison made between the first and the second amino acid. And the E site is for ejection. That ejects RNA transport. We see this technique in further lessons. Make sure you are subscribed. The function of ribosomes is translation of mRNA. mRNA is a short miniac for messenger RNA. He translated to protein by fixing the RNAm and helps the RNA transport to fix on their sites. Also, like we said, he helps the forming of peptide liaison between two amino acids, and the result of that protection of a peptide chain, which turn to protein later on. I will explain this in more details in translation lesson. We have two types of ribosomes. One is free in the cytoplasm and the other is attached in rough reticulum endoplasmic. The free one can regroup together forming as a polysome for very fast translation of the RNAm. The protein are made by the free ribosomes are more likely made for the cell's needs. That means the protein who are made by the free ribosomes are made for the cell needs. That means the cell who gonna consume that protein. The second types is the attached or the fixed ones, and they can't move. And the protein made in this ribosomes attached to reticulum endoplasmic are more likely to export outside the cell, like hormones and antibodies. That's it, guys. This is the end of the lesson. I hope you understand it. So I see you in the next chapter. Goodbye.